Okay, this is a video for the assembly and maybe some on the drafting. Alright, so the first step after you finish all the parts, I'll start a new assembly part. So that is the assembly units inch, and I will save this to the folder where all my parts are. So this way, you do want to make sure your assembly is in the same folder as your parts. Okay. You can change the name as we wish. Then that'll start a new assembly. Then add components. If you have some parts open, then it'll be here. And we'll just start with the the handle and insert at the absolute origin. Apply. And there's a couple of ways to do the assembly. I guess here I can show you how to make a sub-assembly, because our part is relatively easy. You can just go straight from parts to assembly. But sometimes if you have multiple levels, a complicated structure, you can do, for example, like here, you can make one sub-assembly first, then put that sub-assembly into the higher level sub-assembly. Then you can even have more structures. So here I'm going to insert the grip and also absolute origin and just say OK. So I'll use this as the handle assembly. So that will be the lowest level assembly. Okay, and because they are made out of the same file, they are both from the handle. So actually now they're perfectly matched. If somehow you move one of them, it'll be hard to make them back. So what I'll do is I'll first make a new section that's like a cross-section view that you can see things. Then we'll make that one. It's not deleting the things, it's just the display. So I'll use a fit constraint for this face to this face. Okay, that should constrain a little bit, but not all the way. So as you can see, we do want to first constrain the handle, eliminate any degree of freedom. So we'll fix the handle. Then let's see the grip. It should be able to move. Yeah, that's the degree of freedom still left. So we'll apply another constraint, another fit for another pair of faces. With two pairs, it should totally kill the degree of freedom of the grip. So if you want to turn off the section view, you can simply double click, okay, on that section view. Alright, so now that's the one sub-assembly. I can save this as, say, maybe sub-assembly, and that'll be the handle. Okay, so you don't have to do this. You can build a new top level assembly and insert every parts you want. But here I'm just showing you how to use this kind of structure. So apply, that'll be the sub-assembly, and on the other side we can use two parts. And okay, so now we have, you can see the top level assembly, that is a sub-assembly, and those two are the individual parts. So we'll rotate this 180 degrees and okay, and then also we'll select both, because now they're a perfect match. We'll just do a bond, okay, for these two. So in the tree you have to hold shift to multi-select. Then for this, if we move the handle, or if we move the handle, the grip will move along with it. So that's the handles, and we will, let's say we fix this part. So we apply one constraint, kill. Well, when you deal with subassembly, be careful when you try to apply constraint, it'll actually take you into the subassembly. As you can see here, the other handle is grayed out, so be very careful about that. If you want to apply a constraint on a subassembly, you want to select from the tree instead of instead of the individual part from the graphic window. So since we already have the fixed constraint, so we don't have to do anything. Let's try to move it. Okay, even when you try to move it, it'll take you back into the subassembly. So now we'll constrain the other handle, do a invert center. So that center line to this center line. Okay, then also make sure these two are touching each other correctly. If we move this on the axial direction, this is not quite right. So we'll do the touch line from this face to this face. Okay, that should make it behave correctly. And as you can see, this one is not on the origin, so let's try to make it back to the origin, or we can insert another part. Another part is jaw A. Let's insert jaw A. Apply. Okay, so this jaw A is built on the origin based on that hole. So we'll fix this part first, and we'll anchor the handles onto this part. But let's put jaw B inside first. So jaw B here, absolute origin, and we'll rotate jaw B 180 degrees. Okay, and they should match pretty well, like this. And seems like it's not quite right. So what does just do some constraints. First, for the cylinders or for the holes, you're gonna want to align the center line here, and second is the face. This face and this face should touch each other. So that should be enough for jaw B. Okay, we'll try to, it'll go like this. And also these two holes goes into these two holes. Then again, that's center line to center line. Okay, and this side is the same, this center line to this center line. And as you notice that this axial direction is not constrained, so we'll do a center constraint 2 to 2. We'll find the two parallel face, this one and this one. That's a pair. Then we'll try this pair. Yeah, I think this pair is correct. Then F8. Okay, that looks okay. Now you can also try to move this. So I think that's all the mechanism here, really. So we have the major parts here, and we don't really have rivets, and which we didn't do in the project. It is not required, but if you want to, you can add a rivet. as a new part, and that's sort of like a top-down assembly. So we have this machine, we want a function to be realized through a part, and we don't have the part yet. What we do is we build a new model. You can say it's a rivet. Okay, and I don't know the size. Then we can go back to the assembly. For this rivet, we can do a measurement from the top to the bottom. That is 5.53, and then the diameter is 0.47. So let's go back to model 1 for the rivet. We'll insert a design feature cylinder and start from the origin. The diameter is 0.47, the height is 0.53, and say OK. That is the rivet, and without the header. So the head, we can do that when we are in the assembly. Let's just insert the rivet here, absolute origin. Okay, that's fine. Then we'll move this up. So what we do is assembly constraint again. First, the center line, this center line to this center line, and then touch. You want the top to touch this face, and that's not right. Okay, we'll say OK first. Then we find this. Where's that touch? So model 1, that touch. Okay, we can try to reverse it. Okay, it doesn't work. Then we'll delete this. Delete, and move this on the axial direction. Okay, when they're close, we apply the touch align constraint. Okay, so now we still need to add the header, the head. The head diameter is 5.4. Okay, then the height is from this face to this face, so 0.975. Then we can modify the rivets just right here. Double click. Then we do insert design feature cylinder. Oh, oops. So insert design feature cylinder, and we want to say a vector. We'll do negative z direction. A point would be the center of this. Okay, so if you want to, you can really actually measure from here. You can measure diameter from the assembly. Okay, get that number, and the height you can also measure from distance from the top surface to the bottom surface, and okay, so that's the distance you want. And this is the second cylinder. Let's see if we can unite them together. So with the help of the assembly, you will be able to make the rivets within the assembly. Okay, so we can go back to the assembly. So this the same way goes for the rivets here, those two rivets. Okay, but we do need rivets for those this place. The reason being is we have a lock there. So where's the lock? Okay, it's buried inside the drawers. So move, and I guess we already flipped the thing. So it should go here. We will apply assembly constraint from center line to center line. Okay, and we also make the bottom face touch this face. Okay, now we can rotate it a little bit so it's not running into that. Okay, so as you can see, we need a rivet. The lower diameter should be the hole, the same as the hole, and the higher should be about that big. Okay, so before that, actually, we can apply another constraint, bond to make this bond to this, make a constraint. Okay, so this way, when you move this handle, rather you want to move the sub-assembly from here, from the tree, then this lock will move along with the sub-assembly. For the rivets here, we'll again make a new file for the second rivet and insert whatever you want. Yeah, actually we can go back to the assembly, insert, and part 2, which has nothing. Okay, then we can make a cylinder there. So double click model 2 or rivet 2, and you can insert cylinders, design feature cylinder, and we'll see. We can do that from the absolute origin. Okay, it can start from there, then we can move it here, and the diameter we can measure it, this hole here. Now it's on distance, so we'll change that to diameter. Okay, and the height, in real life the rivet is actually a little bit longer than the distance from this top face to the bottom face. So what we'll do is we can change the first measure point onto the very top and say okay, so that is our cylinder, or even you can change that to 0.6. okay, and do apply. So that is the rivet. We'll just say cancel because we already have one. We go back to the top assembly and use constraint to move this rivet into this hole here, and I believe I clicked on the wrong center line. We'll just make sure it's the center line all the time. So center line to the center line, and I think it should be aligned to this. Okay, alright, then we will make a bigger cylinder from here, right? You know the idea. So we'll insert another cylinder. This is a recently used command, and where we're gonna start from is the okay, we'll start from here. Actually, that's not a good position to start from, so we can measure from here to this step how much. Okay, you don't have to do this, but I'm just trying to make something inside the assembly. So the thickness of the lock is 0.057. Okay, then what we'll do is we move this down, minus 0.057. So that'll be the bottom face, and okay. Then the height, we know it's 0.07, so 0.057. The diameter we have to measure from the diameter of this. It just says it will not be associative to the assembly, okay, but we still get the number. So we'll do unite and apply. Okay, so that's the step, but on the top we still have to have a cap to stop it from moving. So this time we go from, we just use invert, pick the center of this, and make the diameter bigger, so 0.3 maybe. And we can see a preview of that. If you feel this is good enough, I think it should be a little bit bigger. Okay, so that could be a rivet, and that looks okay. Then we do an edge blend and make it smaller. So something like that. Alright, and if you want a special profile, you can do a revolve. So I'm done with the rivet, and we can go back to assembly. And it doesn't like the align. We'll use, because that thing has a escalation mark. So what touch align, use auto preferred. Touch line from here to the surface, because that surface disappeared because we just united the cap to the cylinder. So alright, so that is the rivet, and if you want another one, you can insert this one. Now this time we can use by constraint, and okay, it'll ask you what type of constraint you want. And first you need to pick from the part you want to insert, then you pick the center line from the assembly. Okay, that is one. And the second constraint is the face to this face. I will say okay. So something like this. I think the second constraint is actually not right because it has a step. No, oops. I'll go back to the assembly and move this part on the axial direction. Use another assembly constraint for this smaller step to this face. Okay, so now you can see the difference on the left side and right side. There's a gap on the right side. Okay, so now it's pretty much the assembly is done. Okay, and if you don't want to see those constraints when you're taking a picture, you can uncheck those things. Then we also have this show and hide. You can hide datums, hide curves. Also, let's say, yeah, that's it. So that's all solid left. You can try to use true shading, or you can sometimes you can also change the colors. Right click and there's a edit display. You can change the color and also translucency if you want to. So that is the assembly, and then there's we ask for a drafting. So I'm gonna show you how to make a draft. Even I think we showed that a little bit in the lab. So first I want to choose a part. Okay, I could choose this one. It's kind of complicated. I'll choose the lock. So let's start with make it a displayed part. So right click on this, make displayed part. Now we're into this one. Then hide the sketch, otherwise it's going to show up in the drafting. Then switch to drafting. Alrighty, then you can use standard size or template. Just use standard size, say OK. Then if you have some options, well, maybe by default it should be the creation wizard. It'll ask you which part, so we want to use this part. Options, don't have to change anything. Orientation is the main view of your part. So I think this one is okay. The next step is which views you want. Okay, we can use 4 views, or we don't really need this view here. So I'll go back and change that to another view so it's a little bit easier to see. Alright, we'll just leave it like this and finish. Okay, now next step we'll get some dimensions. So we'll use feature parameters, and given your sketch is well dimensioned, then pick the feature first, then click here, then pick the view. I just click on this graphic window, pick this view, and say OK. Now those are the dimensions I did in the sketch. So this one would be here. Okay, you can drag them around and rearrange things. And I don't have the dimension for this. Here you can use infer dimension. So remember, this one is a 3D, so even though you click on a point, it's actually a line projected into this view. So sometimes you're gonna see different things. And maybe we can have a total width, which you can't really see. It's on the sketch, so we can have this dashed line helping us a little bit. And then click here, okay, and close. I'll hide this, and this is totally not up to standard. Okay, I'm sure standard is not like this. So this one is parallel distance. Maybe we'll just use parallel distance from here to here. Okay, that'll give us the thickness of this piece. If you want to, you can make another one, and you can add more dimensions. And I'm happy with this. Then we also ask you for one cross-section view. So we're going to use section view, and first you're going to pick which view you want to cut into a half. So probably this one. Now I'll cut from the origin. We go this way. As you can see, that's actually look from the right to the left, cut along this line. Okay. So if it's hard to see that, we can right click and style. We can change the shading to fully shaded, apply. That's a little bit easier to see. Then you can double click the crosshatch. Open setting, distance, make it smaller, 0.05. That'll be crazy small. Okay, it's not bad. Then we can turn that into shaded as well. So those are the views you want, and you do need two views at least, and one section view. Okay, if you want to, you can add some dimensions here. And that's all for the drafting. If you want to generate a nice looking picture, you can do a file and a plot. And in plot, we have this action here, because all the option here is actually pretty poor. The quality is pretty poor. So you need to open actions, advanced plot, click this button. And with this advanced plot, you can have a setting here. You need to bump up the resolution to at least 200. So if you change that to 200, that'll be pretty high resolution picture. And I have this one preset to 205. And you can say print. It'll ask you where you want to save. I'll save to desktop, this folder, and save. Okay, it'll save right away. So where's that? It's a TIF, and it's not very good. See, it's 200 dpi. It's not enough for a size picture. That's very pixelized. So if you like to, you can change it to maybe 500 dpi. And print, override, okay. and let's see if it's better. So it's much smoother. So you might need to play with the setting a little bit. That is for the plot. So I guess this is all for the project videos. Thank you for watching.